everyone, and welcome back to our course. In this lecture, I'm going to show you how to install Visual Studio. Just go to visualstudio.microsoft.com/downloads and choose which version of Visual Studio you want. We're going to be using Visual Studio 2019 version 16.10, but you can use any version that you like. And just choose free download to download Visual Studio. For the introduction to C++, you can use Visual Studio for Mac if you have a Mac, or for Windows if you have Windows, whatever computer you'd like. But for the Unreal section, we're going to need to use Visual Studio for Windows, because for Unreal, we highly recommend a Windows computer. For the introduction to C++, you could also use RepelIT.com, which is a free online code editor where you can start coding in C++ for free online, and you can use that if you prefer. You can go to /languages/CPP to start coding here in C++, or you can sign up for a free account to be able to save your files. So for the introduction, you can use either an online C++ editor or Visual Studio, but for the Unreal section, you will need Visual Studio. With Visual Studio, make sure you also include the Game Development with C++ option in the installer. So here I am in the installer, and you can modify it after it's been installed, or just include during its installation process. Make sure you include Game Development with C++. You don't need Python, that was just from another project, but you do need to make sure that you have here Game Development with C++. This will allow you to use C++ with Unreal. Okay, so when we get to the Unreal part, you will need this extension. And the extension is completely free as well. You just need enough computer space. Alright, and that is how you can install Visual Studio. Everyone, and welcome back to our course. In this lecture, we're beginning our introduction to C++. So open Visual Studio and hit create a new project. Here we're going to select our project template as a console application. Later in this course, we're going to use Unreal to build our game, so we'll use a combination of Visual Studio and Unreal. But for now, we're going to stick with the console app as we introduce C++. Then press Next, and now you can give your console application here a name. Let's call this Introduction to CPP. As well, choose a location for your project. Here I've selected my folder where I want to save my project. A new folder with the project will be created inside of this location. Alright, then press Create, and that is going to launch your project. Alright, and here we go. Our project has launched. Here we have our main window where we have one file open, and then we also have another window open, the Solution Explorer, which tells you all of the folders and files in your project. If at any time you accidentally close a window or you don't see a window, just go to the Window tab, and here you can find all of the windows that you need. Alright, so here we have our solution on the right hand side shown in the Solution Explorer. At any point, we could drag around these windows and place them as we need. We have here our project folder, Introduction to CPP. We have our references, external dependencies, which are some files that we're dependent on for using C++. We have header files and resource files. These are two folders that are currently empty, but if we built any header or resource files, they would go in here. Then we have source files, which contains the source of our project. Currently, we just have one file there, introduction to cpp.cpp. CPP is the file extension for C++. All right, and here we have that file open. If you want to open a file at any point, you just double click on it and it will pop open here in the main window. Here we have our default file that's created whenever you create a new console application. At the top, we have a comment that explains the file, and a comment is typically written with these 2 forward slashes, and it means that it won't be executed by the compiler. So it's just for you, the developer. And you can delete a comment without affecting the actual code. Then you have an include line, which is telling you that you're including a dependency here known as IOStream. And that is so that we can use different functions like stdcout. This is for printing a line to the console. Inside of this C++ file, we have one default function, the main function. A main function is always going to be running whenever you press play or debug, whenever the application launches. And it's always called int main. This is the syntax for making that main function. It's also kind of like the gate or the entryway to your project. Anytime you see an asterisk beside your file name, that means you need to save the file. So you can go to File and then Save All, or use Control-Shift-S, or just do Control-S to save this one file. We also have some comments below this main function. These are giving us hints for getting started with the project. Again, we can delete comments without affecting our actual project. Again, this standard cout line, this is actually printing a message to the console. We then have these 2 alligator brackets or less than signs. These are a break between this cout line and this hello world line. So it's just a way to separate these 2 units that are part of the same line. Then we have a string in double quotations that says hello world, and then as well \n. And this is the string that we want to print out to the console. And a \n means a line break. Then every line in C++ has to end in a semicolon as a way to finish the line, like a period on a sentence. If you save this and then go to local Windows debugger, or go to debug and then start debugging, you can actually see your console pop up. Look at that. It has popped up here, and I can see some text here that says hello world. Then I have some information that my project exited, and to close the console, I can just press any key to close the window. Alright, so we just saw our console, which is that standard Cout, and then we saw hello world and a line break being printed in the console. This proves that whenever we hit run, this main function is entered, and whatever is inside of the body of the main function is going to be executed. In this case, the body just has this one line, and the body is whatever is inside of these curly brackets. As well, at the bottom left here, you have an error list and an output list. These can be very useful for helping you debug your problem because you'll see errors and warnings as well as messages whenever you run your project. You can also see what happened in detail by going to the output window here. Alright, so this is how you can create a new project, specifically a Windows console project. Alright, next up, let's go ahead and begin by creating some variables. If you're not using Windows, you can create a console application for Mac as well, or whatever other computer you're using. Join me coming up in our next lecture where we will create our first variables to store data. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to build a new C++ project, and in this lecture, we're going to learn how we can now create variables to store data. There are different data types, and you'll find that C++ is similar to other object-oriented programming languages in many ways, for example, in how you create variables, but then there are some unique factors to C++ as a language as well. Let's create our first variable here inside of our main function. So I'm just going to hit enter to create a new line, and then let's create our first integer variable. Here I've used the keyword int, which is the shorthand for integer. And this is how you specify that a variable is storing an integer data type. C++ is a typed language, so you have to specify the data type of your variables. Then let's create some variable here, such as, for example, health. So this is the name of our variable. We've named it health, and we've specified its data type. We could leave this here with just ending the line with a semicolon. And this is the syntax for declaring or creating a variable. You first specify the data type, and then you specify the name of the variable. You can also give the variable a value by using an equal sign. For example, I could give this health value 100. And here I have assigned the value of 100 to be stored in the health variable. So a variable can be thought of as a box to store data. So this way, instead of having to reference health with a number, I can now reference health as a variable. Alright, so notice this syntax. You always have to have the type and the name on the left-hand side of the equal sign. And then you have to have the value on the right-hand side of the equal sign. Okay, so here we've assigned 100 to be the value of the variable named health. And we could call this variable anything we wanted to, but its data type has to be a valid data type. Notice that here int is even colored in blue because int is a keyword. I couldn't call my variable int because int is a keyword that is reserved for data types. Also notice that I have to have the value of health be a whole number. Why is that? Well, it's because I specify the data type to be int, and an int is an integer, which means a whole number that can be positive or negative or 0. So I could have this be negative 100, for example, or I could have it be 0. Okay, let's see here. There we go. But I can't have it be a fraction or a decimal number. I can't have 100.1 because that is no longer an integer. Okay, so here I've declared my health. We could have this back at 100. And we've created our first variable. So now we can even print the variable to the console, similarly to how we see hello world being printed here. We can use stdcout followed by the alligator brackets to specify a break between phrases. And then we could put in the health. All right, then we could add here as well alligator brackets and use std and then end L to end the line. This is typically the preferred way to end a line or make a line break than to use \n. All right, now if we save this, if we hit the debug button, then we'll be able to see 100 is going to be printed out for us here in our console. All right, so that proves we were able to use our first variable. Now there are other data types as well. We're going to talk about primitive data types first. Primitive data types are data types like an int. They are part of the C++ language. You can create your own data types as well, and we'll be doing that later on. Here we can create another integer. For example, we can have an integer for a level, say level 2. So again, same thing. Type, name, equals sign, and then the value. A similar type to an int is known as a float. This is also known as a floating point number, but float is the key word for declaring a float variable. And it's similar to an integer in that it's a number, but a float can contain decimal places. So I could have a float here, for example, my enemy health, and I could set their health to 30.3. All right, and here if I'm using 0.3, I have to add an F at the end to specify that it's a float type. So this is just the syntax. If you're building a float, you have to put an F at the end if you're including decimal places. You could also declare a float just like you did the integer. For example, you could have a float here that says my health, and I could have it be 20, and then I could just end it like that. All right, without the F. But as soon as you introduce decimal places, you then have to add in this F. All right, and we can test out all of the variables that we just made. Let's just copy these cout lines and replace these with enemy health, and let's replace them with my health as well. So I'm just printing out to the console the value of enemy health and the value of my health. And if I hit debug, I can see those in my console. I have 100, then I have 30.3, then I have 20. All right, so I was able to create these variables. Similar to a float is also a double, another primitive type. This can also store decimal places, positive and negative, but a double can just store twice as many decimal places as a float. That's why it's called a double. For example, let's say you had a huge health, right? Or maybe perhaps a huge fraction of health, but regardless, you can have here 10.99999. So you can have a lot of decimal places at the end here. All right, so that is how you can create a double. But again, a double doesn't need to have decimal places. You could just have a double be 10. Another primitive data type is known as the Boolean. This is created with the keyword bool. This is slightly different. It represents a true or false value. For example, I could have here playing, and I could set this to equal true if I am playing in the game. This Boolean comes from the mathematician George Boole, and a Boolean value can only be true or false. It can't be a number or a string. It has to be only true or false. And notice that true and false, they're not inside of any quotation marks. If I put true into quotation marks, that would make it a string, no longer a Boolean data type. Same with integers and floats and doubles. They have to be outside of any kind of quotation marks. Different though is indeed a string. A string is made with standard here and then string. All right, so this is slightly different. I'm now referring to this namespace, the standard namespace, in order to create this data type, because a string is not a primitive part of C++. A string is its own reference type, but it's very commonly used. And if we want to create a string, again, we first place the type, then we place the name of the variable. We could have it be name or player name. And then we assign it the value. But a string, this stores a piece of text, so it has to be in double quotation marks, not single quotation marks. Here I can give my player a name such as Joe. Okay, then I can now paste out the value of Joe to make sure it's working. It's good practice to test your code often and also to save it often. All right, here let's print out the player name. I'm going to press debug. And this time, look at that, we see Joe being printed in the console. Similarly to a string is a character. Notice that this is a primitive again. And this is going to store just one letter. So it can only store maximum one character. For example, first letter. And to declare the value of a character, you use single quotation marks. Okay, so you don't use double quotation marks. Be careful about that. And this can be either capital or lowercase. Okay, then we could print out the value of that character, just like we did with all of our other variables. Using this console out, let's hit debug and let's see that J. There it is. Awesome, and that is how you can create variables inside of C++. We're going to use variables a lot. They are the basic atoms of programming because they store data. Join me coming up next. We're going to learn how we can perform tasks with functions. I will see you in the next lecture. Hello everyone and welcome back to our course. In the previous lecture, we learned how to build variables to store data. And in this lecture, we're going to learn how to build functions to perform tasks. And I've also zoomed in here my text size so you can see a bit easier. All right, first let's create some kind of task that we want to perform. For example, what if we wanted to calculate how much health our player had remaining every time they were attacked? Okay, we can create this task in our main function to start, and then we'll create a separate function. Because as you can see, we already have a lot of code inside of the main function. And typically, you want to separate all of your functionality into smaller functions. It's just a lot cleaner. For example, we could even already make a function. We could call this our build variables function. And we could put in all of the code we already have into that build variables function. That way it's not all just dumped into the main function. So here I have called the function, but now I have to actually create it. If I'm calling it, that means I'm putting it to use, but in order to use it, it has to be created. Let's create it above the main function, because if we want the main function to be able to access it, it has to be declared above the main function. Code is read or compiled from top down. So if I am using a function that's created later on in the file, you'll get an error that says that the function could not be found. So that's why we have to create the function above where it's being used. To create a function, it's similar to a variable in that first you specify the type. In this case, it's not the data type of the function itself, but it is the return type of the function. For example, if a function returns or stores an integer, then you would use int. If a function doesn't store any value, you can just use void, because functions don't have to store values. Then we have to give this function a name, build variables. It has to be the same name as we used to call it. After that, we have these two parentheses. This is for passing in any parameters or extra information that the function needs to be able to perform. And we'll look at parameters shortly later on. After that, we have, similar to our main function, we have curly brackets. Inside of the curly brackets is where we put the function body, or whatever task the function is going to perform. All right, here we call this build variables. So let's just take all of the variables that we created, all of that code, and let's cut it from the main function, and let's just paste it right into build variables. So you can cut with just edit, cut, or Control X, and then paste or Control V. So here I have just moved all of my code from my main function into build variables. And you can use these minus and plus signs to toggle closed and open these functions. All right, so now my code is a bit cleaner, because instead of dumping everything into one main function, it's separated into these little pieces. And that's a lot more maintainable over time. So now if I press debug, you're going to see everything will run exactly as it did before. We still have hello world, all of our variables printed, all of those values. That's because our function is just doing everything that we wanted the main function to do, but we've just separated it. This is similar to a macro if you're familiar with Excel, perhaps. This is a little task that can be called over and over again. For example, we could copy and paste this line and then have the function do all of its tasks twice. So this is great for saving us time, because instead of having to write all those lines of code again, all we had to do was call the function this second time. All right, next let's create a function that is going to perform a new task. Like we mentioned, calculate how much health a player has remaining. Again, let's create it above the main function because we're going to use it or call it in the main function. Here, this function is going to be void again. It won't return any value. Later on, we'll look at functions that do return values. And we're going to call this calculate remaining health. You want to have descriptive function names where possible. You don't want to just name your functions, for example, void x, and then just do it like this. That can be tempting to save time, but it's really easy to forget what your code is supposed to do, even if you just come back and look at it tomorrow. So you want to be as clear as possible with your naming. Also notice some of the casing here. For our variables, if a variable is created inside of a function, it's known as a local variable, so it has just lower casing. This is actually known as camel casing if you have more than one word in that variable, which means it's all lowercase except for the first letter of the words that are after the first word. Okay, that is for variables that are built inside of functions. Functions themselves, however, have Pascal casing or title casing, where you just title it like you capitalize every single word in the name. Okay, here inside of calculate remaining health, let's write some kind of task. For example, we can create our float variable called our player health, and we can assign this to equal 100. You can do 100.0f as well if we wanted to. Then let's create a float damage. Perhaps this is equal to 10.0f. And by the way, this 0.0 is not even necessary. You can just do 100 point. And you don't even need the point f here. You can just do 100. Okay, so it's up to you. Next up, let's now perform some mathematical operation. We can take player health and we can subtract the damage, because the result of that is going to be our remaining health. If we have 100 health, but then we get damaged by 10, then we have 90 left over. Okay, so here we've just performed a basic mathematical operation, and you can do a whole bunch of mathematical operations. Like you can do, for example, addition, division, multiplication. We've seen subtraction. You can also do even more by using the math library. You can implement pi, linear algebra, and more. All right, so here we have created 3 variables and performed a mathematical operation. And then let's print out our remaining health. We'll use here cout, and then we'll print out remaining health. And we'll add here the value of the variable remaining health. And we'll end the line with this end line. Okay, now if we call this function, calculate remaining health, we'll actually see it execute its task. Just creating this function, this is known as initializing it. So we're giving it some kind of task. We're giving it a body. But if we want this function to actually be put to use, you have to call it. Just creating it doesn't actually run it, it just allows it to be run. So somewhere, for example, in the main function, we have to call calculate remaining health. All right, there we go. We can delete the calls to build variables. So now we have created calculate remaining health, and then we're calling it to be used. Don't forget to call it, because if you don't call it, it won't actually ever execute. It'll just be compiled or read, but it won't execute. Okay, now let's hit debug, which is going to pop open our console. And here we can see remaining health is 90. Awesome. Okay, so that means we were able to successfully run our function. By the way, you'll also notice there's a build option next to debug that allows you to build the solution, but this won't actually pop open the console. So instead, it's best to go to debug and then start debugging, which is going to open the console. That's the easiest way to test out your console application. All right, so that is how you can create a function to perform a task. Join me coming up next. We're going to learn how to build functions with parameters and also with a return type that is not void. I will see you in the next lecture. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to build functions, and in this lecture, we're going to learn how to build functions that take in parameters. All right, so we already have calculate remaining health. Let's build another calculate remaining health, but this time it will take in parameters. So we can actually create another function with the name calculate remaining health. But if you just leave it like this with the same number of parameters, then you won't be able to create this function. You'll get an error. What we have to do is overload the function, which means change the parameters that it takes in. If you want to create a function with the exact same name, you have to overload its parameters. All right, so here I would put in, for example, a float that says my player health and another float for my damage. Okay, so here I have passed in two parameters into the function. Notice that for parameters, you have to specify the data type of the parameter, and then you pass in the name that you want to use for your parameter, which can be any name. Here we have two parameters, which are two floats, and this is just extra information that we want to pass to this function. So now, whenever we call our second calculate remaining health, we have to pass in two parameters if we want to specifically refer to the second instance of calculate remaining health. For that, we have to pass in some player health and some damage. So for example, I could pass in here 70 as my player health and then 20 as my damage. Let's create those into variables in the main function just to be a bit more clear. about what these values mean. Typically, you don't want to leave numbers just lying around like this without being stored in a variable. These are called magic numbers, where you want to avoid those at all costs, because if you have magic numbers that are not stored in a variable or a constant, it means that it's less clear what that value actually is. What is this 70? What is that 20? It can be really hard to understand. So let's create variables for those. I'm going to create a float called player health and set it to equal 70, and then a float called damage and set it to equal 20. All right, and then I'm going to pass in those variables into the function instead of just using the values. Notice that these don't actually have to have the same name as the parameter names. This could be called player health 44, or not 44, but player health var, for example, for variable. Okay, then you could pass in player health var. So you don't have to have the names match. You can pass in any name in here. So we're passing in player health var, and let's just do damage var for consistency. Okay. And here, because we've passed in two parameters, the compiler will know it should not enter this first function, which takes in 0 parameters, but instead it should enter this second function that is the second instance of calculate remaining health, which has these two parameters. Note that you do have to pass in the parameters in order. So I couldn't put in damage var and then player health var, because then I would be using the wrong numbers. I'd be using 20 as my player health and then 70 as my damage, which I don't want to do. So you have to pay attention that you pass in the parameters in the correct order. Okay, so I've made a call to this function, but now what do I want this function to actually do? Well, I could have it do the same thing as its first instance, okay? Its first option. I could just take the player health parameter and damage, and I could calculate the remaining health. But you see, inside of the first calculate remaining health, we had to actually create those variables ourselves. But inside of this second remaining health, we have those variables passed into us, so we can already put them to use. We can already make a float that says remaining health, and we can use player health minus damage. And here I'm putting to use the parameters. All right, then I can print out the remaining health. Let's put this as number 1, remaining health, and then let's print out the remaining health, followed by an end line. And let's just add a 0 to the one above that. That way we can just differentiate these two lines. So you can see the two functions are similar in that they both perform the same task, but one of them had to create the variables itself, whereas the other one got the variables passed into them. And that's very important and useful, because typically when you want to calculate a player's health, you don't want to have a static value for the health and the damage. The player's health changes throughout the game, and so does damage. So you want that to be a variable that could be passed in with a different value each time. So for example, I could call calculate remaining health, and I could pass in different values this time. I could pass in 10 and I could pass in 1. Of course, these are magic numbers, but you get the idea. We can pass in 10 and 1, and we're calling the same function 2 times, but with different variables. So we'll get a different result each time. Okay, let's hit debug to check out our results. If you have any problems with getting the same result, just check your error list to see what errors you have and fix your code with those errors. So here we can see first our remaining health was 90. That was that first call to the non-parameterized function. Then we have our remaining health as 50, which was 70 minus 20. Then we have remaining health as 9, which was the 10 minus 1. So that's how we can create functions that take in parameters. We can also create functions that are not just void, but that actually store a value. So we'll talk about that coming up in the next lecture. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to build functions that take in parameters. They can take in some values and then put them to use. In this lecture, we're going to learn how to build functions that can return values or store values. Because previously, all of the functions that we have built have been void, which means that they don't return any value or store any value. But a function can actually act as a variable, so meaning that it can store and return a value. For example, when calculating the remaining health, instead of just printing out the remaining health, we often might want to instead store the remaining health and put it to use somewhere else. So how do we store our remaining health? Well, let's create a new function. We're going to call this getRemainingHealth, and we're going to have it return the remaining health, which is a float data type. So the return type of the variable is going to be float instead of void. Then we'll pass in the name of the function, which is getRemainingHealth. This is just a name we decided upon. And we'll open up the parameters and the function body. The function can take in a float for the player health and a float for damage. Optionally, we could just call getRemainingHealth from calculateRemainingHealth, or we could just create it and have it perform its functionality from scratch. If we want to have it perform the functionality from scratch, then we just create here a float remaining health and we subtract the damage from the player health. The difference though now is because our function is not void, it has to return a value. And the value has to be a float. For example, we could return remaining health. Or we could return a float like 10.0f. Okay? In this case, we want to return the remaining health because that's the point of the function. Notice that the return value has to be a float because that is the return type of the function. This return statement should also be the last line because as soon as the return statement is run, the function actually exits. So if I had some other code down here, for example, if I wanted to take player health and multiply it by damage for some reason, okay, multiply it, not point to it. Well, this code, you notice it's even grayed out because actually it will never be reached. Because once a return statement has run in a function, we are going to immediately jump out of the function. Okay, so that's why return is going to be the last line. And a function can only return the one value. So there we go. It could return multiple values if you had a collection of values stored in one variable. But it can't return, for example, remaining health and then player health like that. We can't do that. We have to just return one variable. All right, and that is how we can build a function that stores a value. So let's put this get remaining health to the test. Okay, let's here call our std cout, and then let's paste here our remaining health, and then std, and then end line. Okay, here instead of remaining health, I want to use the function get remaining health. And I need to pass in some values. I need to pass in a player health and a damage. So we could just pass in the same values, player health var and damage var. Okay, and I can just remove these previous calls so they don't get in our way. So here, now we're just declaring these two variables inside of the main function, and then we're calling get remaining health inside of a console outline. So what do you think is going to be logged out in the console if we're just calling get remaining health? Well, let's put it to the test. Let's hit debug, and that is going to launch our console. And look at that, we can see 50 has been logged in the console because we took 70 and we subtracted 20 inside of this function get remaining health. The return value of that was 50. So that is exactly what's printed out here. So as you can see, we're using a function like a variable, but the difference is that a function can actually perform a task before it returns its value, whereas a variable, it just stores a value. It doesn't perform any task. All right, join me coming up in our next lecture. We're going to continue learning the fundamentals of programming, and we're going to learn how to separate our code and separate code flow using conditionals or if statements. This will allow us to go down a certain branch of game logic or game flow depending on a condition that has been met. I will see you in the next lecture. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to build functions that return values. And in this lecture, we're going to learn how to build conditionals. Conditionals allow you to separate your code flow. For example, if the player's health is 0, then the player is dead. Or if the player has 100 XP, the player should level up. We can perform some kind of action based on whether or not a condition or an event has been met. So let's go back into our project, and we can remove our code from the main function. And let's write some conditionals here instead. To create a conditional, you use the keyword if, which is known as an if statement. And then similar to a function, you open up these parentheses and then curly brackets for the body of the if statement. Inside of the parentheses here, instead of passing parameters, what you have to pass in is a condition that must pass as true for the code inside of the condition to run. This could be as simple as just if true, which means that the code in the if statement's body will always run. Then here I could call to print out a string such as the condition is true, and then end the line. So here we have our condition set up. If this condition passes as true, which it will in this case because true is true. This is a Boolean value, true by the way, not a string. Only if the condition passes as true will the body be executed. If the condition passes as false, the body will be skipped. Let's go ahead and put this to the test by hitting debug. And here we can see we get the message the condition is true. That means that the body of the if statement was entered. But what if we had here if false instead? Well, the compiler is going to evaluate the if statement's condition. And only if the condition passes as true will the body run. In this case, the condition is not true, it's false. So if we hit debug this time, we will see we actually don't get any message logged. Alright, so we did not enter the if statement's body. Another example of a condition is, for example, if 4 or 5 is less than 6. Alright, so here we've passed in a condition. We're testing if one number is less than another. So in this case, do you think the body of the if statement will be entered? Let's hit debug and find out. Look at that. The condition is true is logged. That's because 5 is less than 6. What if we had here something that was not true, like if 7 is less than 6? Well, this time 7 is not less than 6. So do you think the if statement's body will be entered? Well, let's find out. And looks like no, it did not execute. That's because 7 is not less than 6. So this condition evaluated to false. And if the condition evaluates to false, the if statement's body will not be entered. We can also do this with variables. For example, I could create a variable such as an integer that I will call my health, and I could set this to equal 10. Then I could perform a check. I can check if health is less than a certain value, such as if health is less than 0. If health is less than 0, we can say you are dead because you don't have any more health left. So in this case, if I hit debug, I'm not going to see any condition passing as true, so I don't see any code logged because health is not less than 0. Health is 10. But what if health was -3? Well, now if I hit debug, I will see you are dead because the condition passed as true. As well as having these if statements, you can also have else statements. So you can append an else statement onto an if statement. An else statement does not run independently. It has to be attached to an if statement. And what this does is it's going to run code as a backup. So if the condition passes as false, then we can run the code inside of the else statement. So we can just paste some code into this else statement and say, you are alive. So here what we're testing is, if health is less than 0, we'll print you are dead. Otherwise, if the condition passes as false, then we'll enter the body of the else statement. If the condition passes as true, however, we will skip over the else statement. So if I hit run now, I'm going to get the message, you are dead, because the first statement, the first condition, if health is less than 0, that passed as true. What if we changed health, however, to 43 instead? Now if I hit run, I'm going to see you are alive. That's because the if statement's condition was evaluated to false. 43 is not less than 0. So the if statement's body was completely skipped over, saving us time, and instead the else statement's body was run. You can also make else if statements in between these two or in place of them. For example, you could have an else if statement that says, if health is greater than 40. In that case, we could print something like, you have a lot of health. Okay? So here, an else if statement is also dependent on an if statement. It cannot stand alone. It has to be chained to an if statement. And again, its condition is only going to be evaluated if the if statement above it was evaluated to false. So we go down the chain. If this if statement's condition evaluates to true, we'll completely skip over the rest of the chain. So now we can hit debug and we can test this out, and we see you have a lot of health. Okay, but what if, you may be wondering, what if none of these pass as true? What if our health is, for example, negative 43? Well, actually, if it was negative 43, it would pass here the first if statement. But let's say it didn't pass the if statement. What if we had here, if it was less than 0, we had this 43, and we had this, let's say, 33 instead. What if we had health being 33? In that case, it wouldn't pass the first if statement's condition, but it also would not pass the second if statement's condition. Well, that is actually totally fine. We just won't have any of the code be executed. What happens is the compiler checks the first if statement. It finds its condition is false, so it goes to the else if statement next, and it finds its condition to be false as well. So it just skips over and goes to whatever line of code you have next. And you can have as many of these else if statements as you want. For example, you could keep checking to see if health is greater than 50. And you don't even need to necessarily have any content in the body. In terms of the else statement, you can only have one, and it has to be the last one, because this is the default case. It's what happens if none of the previous ones in the chain evaluated to true. This is like your backup. So that is how you can create an if statement as well as a chain with else if and else. And that is an introduction to conditionals. So with conditionals, we can separate our code flow, and that's quite useful because imagine if we couldn't separate our code flow and we had to have everything happen. Well, then how could we ever kill a player or set a condition or change the player's health? You have to have conditions. They're quite fundamental. Join me coming up in our next section. We're going to continue learning the fundamentals of C++, and we'll talk about a topic that is quite unique to C++, known as pointers as well as references. These can be quite separate from other programming languages, so it's a unique factor about C++. I will see you in that next section.